Hello everyone and welcome to Mr. Ahmed's video screencasts for Math 20. Today's topic is 3.3, chapter 3.3, that deals with volume and capacity of prisms and cylinders. So getting started, a volume is just a measure of the amount of space that a 3D object occupies. However, the capacity of it is how much it can hold, and this is usually expressed in liters. Okay, so there's a difference between the two. Volume is sorry. Volume is the measure of the amount of sorry. So volume is a measure of the amount of space that it occupies, usually expressed either as in meter cubed or centimeters cubed, whereas capacity of a 3D object is more talking in terms of how much it can hold in terms of liters. Okay, so getting right to it, a rectangular prism that has a base that is 15 centimeters by 12 centimeters and a height of 20 centimeters, and it's asking you to figure out the volume of the prism. So just give me 1 second here. Okay, so once again, I am sick while making these screencasts, so if you'll just bear with me. So a rectangular prism has the following dimensions. Now, all we have to do right now is we've just got to figure out, so draw a diagram, you just draw a 3D rectangular prism and calculate the volume of the prism. So calculating the volume of the prism, you just got to go length times width times height. Okay, so that's kind of what you know so far is that the volume of a prism is usually the length times the width times the height. So 15 times 12 times 20. Okay, so I'll have you notice that when we did 15 times 12 here, it's got a base that's 15 centimeters by 12 centimeters. You actually, by going 15 times 12, by multiplying 15 by 12, you actually just figured out the area of the base, and then you took the area of that base and multiplied it by the height of the prism. Okay, so the length times the width is the area of your rectangular prism, of the base of your rectangular prism, and then take that area and multiply it by the height through which that area extends, then that is therefore the volume. So I'm just kind of pointing that out right now because we'll be talking about that in a few minutes when we deal with area of cylinders. Okay, so that gave us 3,600 as being the volume in centimeters cubed of the prism. Now it's asking you to calculate the capacity of the first prism. Now to do that, one thing you guys need to know is that 1,000 centimeters cubed as a volume is equal to 1 liter in capacity. So that means that 1 liter of a fluid or a liquid will occupy 1,000 centimeters cubed. Okay, so going right down to this, if it's 1,000 centimeters cubed for each 1 liter, then you take your 3,600 and you divide it by 1,000. So technically, you should be able to fit 3.6 liters in there. Okay, so that's kind of what your workbook does show you. Since 1 liter equals 1,000 centimeters cubed, you take your 3,600 centimeters cubed, you divide them by 1,000 to figure out how many liters you can fit in there. So each prism has a capacity. The prism, sorry, has a capacity of 3.6 liters. So at this point, you can pause the video and try out the Build Your Skills questions on page 171 of your workbook. Otherwise, moving right on to example 2, a rectangular prism that has a square base with side lengths of 7 centimeters. Its volume is 392. Calculate the height of the prism. So you'll recall what I just said a minute ago when I talked about figuring out the volume. I had told you that it was actually the area of the base times the height. Okay, so and again we'll see that in more detail when we start talking about the volume of cylinders. But the volume, you know how you go length times width times height? Well, that length and that width is actually the area of the base, and then multiply it by its height. Now, if it's a square base with side lengths of 7, that means that the square base is actually 7 times 7. The area of the base is 49. So 392 total volume divided by area of the base should give me the height through which that extends, and that's 8. And that's kind of what your workbook is showing you there. Okay. Uh, at this point, you can pause the video and work on the Build Your Skills questions that start on page 172 of your workbook. Moving right on to example 3, it's asking you to calculate the volume and the capacity of the composite prism. So first of all, let's figure out the volume. Now, it is a composite prism, so you're going to have to split this up into 2 different shapes. What I'm going to do is I'm going to draw a line from this point right here to here, and I'm going to figure out the individual volumes of this little rectangle right here and this big rectangular prism down here. Okay, so I've got 2 rectangular prisms by drawing a line from here to here, and I can figure out their individual volumes and then add those together. Okay, so the volume of this one right here, the bottom one, will just be length times width, which gives you the area of the base, times height, which is 7.5. So doing that, 16.8 times 6.6, that gives me the area of the base, and then I multiply by the height through which that extends. So it's times 7.5. So the volume of that bigger rectangular prism is 831.6. I'm just going to jot that down. Okay. Now I've got to figure out the area, the volume of this rectangular prism up here. Okay. Now I got its height, I got its width. Now I would also probably need its length right here, and happily enough, its length, or this width, or whatever you want to call it, right? This length or width right here would be equal to this, which is actually equal to this. So this is actually 6.6 centimeters. So this right here would be 6.6 centimeters. So let's do that. Let's figure out the area of this base right here. So this is 6.6 centimeters. This is 9.4 right here, as indicated by this. So we're actually just figuring out the area of this square right here, or this rectangle right here. So 9.4 times 6.6. Okay, 9.4 times 6.6 gives us the area of this, and then times the height through which that extends. So times 4.2. So the area of my smaller rectangular prism is 260.568, which I'll now add to the volume of my rectangular prism is 260.568, which I would now add to the total volume, the volume of this the bigger rectangular prism down here, which we had just calculated earlier as being 831.6. So that gives us 1092.2 roughly. So 1092.2. That's what they did here. Well, instead of here they showed you that they split it like this, whereas we split it like that. It really doesn't matter as long as your final value is 1092.2 centimeters cubed. Okay. Now, however, I forgot also to talk about the capacity. Now, the capacity, once again, it's 1,000 centimeters cubed for 1 liter. So we just divide our current volume by 1,000 to figure out how many liters that is. That's 1.09 liters. Okay, so it would be able to fit 1.09 liters or 1.1 liters. Okay, so at this point you can pause the video and work on the Build Your Skills questions on page 175 of your workbook. If you'll just excuse me for 1 second. Okay, now we're working with the volume of cylinders, and here's exactly why I was talking to you guys about figuring out the area of the base and then multiplying it by the height. So the area of the base, this is for the volume of cylinders, right? So the area of the base times the height through which that extends. Okay, the area of your base, the base of a cylinder, is pi r squared. It's a circle. So pi r squared times the height through which that extends. So here you go. There's the formula. Pi r squared times the height through which that extends. Okay. So example 4 is asking you for a can of tomato sauce has a radius of 3.8 centimeters and a height of 10.2 centimeters. What is the volume of the can? So you figure out the area of the base, so pi r squared. So this is my r, so I'm going to square that first. So 3.8 squared. There's my r squared, okay? And then times pi. So this is the area of my base. And I would then take that and multiply it by the height through which that extends. So times 10.2. Okay, so you get 462.7. And then, so that, once again, just to let you know what I just did, I figured out the base of the area of the base. The base is a circle, so pi r squared. Okay, so pi times r squared, so 3.8 squared times pi. And then that multiplied by 10.2, which is the height through which that extends. And you get 462.72 roughly being the volume. Now it's asking you how much tomato sauce in liters does a can hold. So at this point you divide by 1,000 because you know that 1,000 centimeters cubed is 1 liter. Well, that means that 462.7 centimeters cubed is 0.4627 liters. So there you go. And then your workbook decides to round that up to 0.5 liters. Okay. At this point, you can pause the video and get to work on the Build Your Skills questions on page 178. You'll also notice that your Practice Your New Skills questions are also found on the following page on page 179, which concludes this little subtopic.